Well, hello, good afternoon, and a big welcome to you all on behalf of Marine Civils at Sea Work. I'm absolutely delighted to be able to give this opening address to this first webinar of two called Decarbonisation, What It Means for You and How It Can Help Your Business, a focus on HVO Fuels. We were looking for a snappier title, but we thought, well, that does what it says on the tin, so hopefully it suffices. My name is Peter Crossland, and I'm the National Civil Engineering Director for SECA, which is the Civil Engineering Contractors Association. For those who don't know us, SECA is the representative organisation for the UK's civil engineering contractors. So our members range from Tier 1 through to Tier 3 and SME specialists who deliver upwards of between 70 and 80% on all civil engineering activity in the UK. And by infrastructure, I mean sort of highways, rail, energy, utilities, digital, and of course water. And included in that is work with the water companies, capital projects, and then flooding, marine, coastal, etc. So activities that sit very well with this 3-day event, I think. I should also say that I'm absolutely thrilled for SECA to be associated with this webinar, and to say it's been a long time in the making is a slight understatement, but it has been delayed for obvious and very well-known reasons. However, I do feel that the timing is perfect so that we can now at least raise the awareness around HVOs and other alternative fuels, particularly given the focus from the government on reducing carbon by 2050, or even net zero by 2050. I mean, it's interesting to note that some clients have set even more demanding timescales, even 2030 in some cases, and I'm sure we'll hear more about that later. SECA have been championing the cause around HVOs for a good few years now, and I can go back to a presentation we had from industry just over 3 years ago, which extolled the virtues of paraffinic fuels. And there was a slight interest, if not a heavy degree of caution around its use. But it's wonderful to see the industry changing, and hopefully the presentations today will help those who are still uncertain of whether to make that change or not. And hopefully it's the former, not the latter. For me, there's a real double-edged sword to using HVOs. And without stealing the presenter's thunder, if you aren't convinced on the grounds of saving fossil fuels and the associated savings on carbon and potentially cost, as I see these two are inextricably linked, there is also the health aspect. As we know, diesel engine exhaust emissions can be highly polluting, not only to the atmosphere, but also to an individual's health. It is well documented by the HSE that exposure to these emissions can lead to both lung and bladder cancer. Around 100,000 workers are exposed to fumes in the workplace each year, and very sadly, some will die from these diseases. And by coincidence, I was talking to a piling contractor, a member of SECA, recently about the up-and-coming industry initiative called Stop, Make a Change. Runs from October the 11th, which is next Monday, through to the 22nd. And this is something that SECA are also supporting. The contractor wanted to know what topics we were covering, and I went through the list of health, safety and wellbeing suggestions with them. However, as an aside, I also asked if they were using HVOs or similar in their piling rigs. The reason I asked was that for piling operations, the plant and site personnel are all pretty static most of the time, and the workforce aren't really able to avoid the fumes easily, apart from obviously using PPE and RPE. And we all know that wearing of these items is not very well followed. So, given the scenario, I asked if they had considered using an alternative to diesel. And after a short conversation with their fleet manager, who was unaware of HVOs, the response came back, "We're on it." So change can happen. And if we can do something about this, I think we should. So hopefully the presentations will provide further evidence and reasoning for you to do so. Before we move on to the presentations, there are just a few things I need to mention with regard to the webinar etiquette. And I'm sure you're all familiar with these by now, but at risk of repeating what is common knowledge, I'll just run through them. This session will be recorded. I think it says so on the top of the screen. So if you aren't able to follow the whole session, you'll be able to access it later, and I'm sure details will be made available. The public chat function is available to use throughout the session, which we welcome delegates to use to make any introductions and comments. Use the chat function to ask questions, as it makes the admin slightly more complicated. There is also a private chat function, and if you have any issues or comments for the host, please use the private section of the chat function, which allows you to send private messages to specific people. Administration for the session will be listed here. For the Q&A, we will give the opportunity for delegates to ask questions to the panel at the end of the session. This feature is found next to the chat function, so please type any questions in here throughout the event and the moderator will read these out at the end. If you are directing your questions to a specific speaker, please provide the speaker's name in the question. And if you are using a mobile or tablet, please note that the chat function may be hidden and can be accessed by clicking a blue speech bubble icon. So thank you for listening, and I do hope you enjoy the webinar. I would quickly like to take this opportunity to thank Chris Castley from the CPA, which is the Construction Plant Hire Association, for their support in bringing this event to you today. And I should also like to thank the presenters for all their efforts and taking the time out of their very busy schedules to speak today. I'll now hand over to Chris to take you through the webinar. Thank you.
Good afternoon, everybody. Many thanks, Peter, for your very kind introduction. I'm Chris Castley. I'm the Policy Manager at the Construction Plant Hire Association. We basically represent around about 3/4 of the plant hire sector in the UK, a sector worth about £4 billion to the UK economy. Obviously, within construction itself, we're there at the start, we're there at the bottom, from the foundations all the way to finishing off buildings and major infrastructure. It's really timely that we're having this debate around decarbonisation. We're just a few weeks away from COP26, the major global event where we talk about what decarbonisation means, what the future looks like. And obviously we are, as Peter says, coming out from the pandemic. What sort of future economy are we looking at? Certainly this week we've seen a lot of talk at the Conservative Party conference around the shape of the economy and what it means, and decarbonisation is clearly going to be a major part of that. So this focus on HVO fuels, their use, their development, and how they can be used as part of a decarbonisation strategy within business is timely indeed. We have 3 excellent speakers lined up today for you all. We have Andy Powell from the Environment Agency, we have Simon Lawford from Crown Oil, and we have James McLean, who's from Land and Water Group. Firstly, we'll be starting with Andy Powell. Andy is the Innovation Manager at the Environment Agency. He's part of the delivery of the Environment Agency's £5.2 billion capital programme, but he also looks at other aspects of their wider asset management activities. Andy and his team work closely with delivery partners, supply chain and colleagues across the Environment Agency in initiating, coordinating and supporting innovative practices and promoting best activities, how to decarbonise. And Andy's worked for the Environment Agency in a range of technical roles. This is both in flood and coastal risk management, but also landfill engineering and contaminated land remediation, especially early on in his career. The common thread through these roles is about collaboration and with others, driving forward innovative activities and how sustainable engineering solutions and initiatives can be brought forward. Without any further ado, I'd like to hand over to Andy and his presentation. Over to you, Andy. Thank you.
Thanks very much. Hi, everyone. So I'm going to start out a bit broader than sort of alternative fuels. I'm going to talk a little bit about the Environment Agency's net zero carbon target by and then talk about a collaborative task and finish group that we ran looking at our priority areas around construction and the carbon footprint in some of those key aspects, and then finishing up around some of the specific elements around plant and fuels. So I guess the first thing to say is our net zero carbon target by 2030 is just one part of our wider sustainability strategy called Emission 2030. In 2019, we committed to net zero carbon by 2030 as a key part of that, and that means for us it's a science-based target. So we set a specific baseline at that time, and we in effect are looking at 45% reduction on that baseline, and then by 2030, and then we'd be looking at projects to offset the rest in terms of locking up and sequestering carbon. So when we set that baseline, it's quite apparent to us that we've had a really strong focus on our direct operational activities in recent years, with some really significant reductions in that. Sort of 40% reductions in our direct emissions, which is what you can see in the green section on the left, which is then blown out on the right. But in reality, you can see from that left-hand pie chart that in blue, bottom blue there, our indirect activities, primarily through our construction projects, our flood and coastal risk management projects, and some other projects as well, are a significant part of our total footprint, so representing over half of our footprint. So hence we've got a really strong focus on that area, but not just that area alone. We're still looking at many of the other direct contributors as well. So things like our fleet, looking at electrifying our fleet by 2023, and the vans by 2025. But I'm going to focus on our construction activities today. So the first thing to say, I'm going to zone in to talk about sort of construction materials, products, techniques, which are through our engineering standards. But it's really key that we don't miss out the key part, that it's about getting the right construction solution from the outset, and in some cases there may not be a construction solution. So that's a key part of our approach, and making sure that our business case processes and other processes make sure we get the right solution from the outset before we then look to optimize delivery of that solution and reduce carbon as part of that. So when we are looking to reduce the carbon in the way that we deliver the schemes, we knew what our priority areas were in terms of where the kind of carbon sat, both embodied and whole life, and primarily the focus is on embodied carbon in our construction activities, because our assets tend to be sort of in the main civil assets, and relatively sort of high embodied carbon, apart from the sort of pumping stations, which is a separate piece of work going on there. So we set up a collaborative task and finish group with our delivery partners, which was co-commissioned, and in fact we split it down into some key themes where different delivery partners were leading different themes. So you can see up there things like site setup, plant transport, asset repair solutions, modern methods of construction, concrete reinforcement, steel piles, and the classic other category. But we very much, whilst we had leads, they were supported by many other colleagues in other organizations that work with us, and helping to sort of bring together proposals, comment on proposals, is a really useful exercise to go through that, to see how we can challenge our engineering requirements. And in effect, this is all about looking at innovation and best practice, which is already out there, and just making that business as usual, making a decision to make that business as usual together. So I'm going to take you through some of those as just high-level examples. So in terms of concrete and reinforcement, we've done some work and knew that, you know, if half of our total carbon footprint is from construction, we know that more than half of that is from concrete use in our construction activity. So you know, a really good area for us to focus on, which we did. There's a lot of there's a range of ways that you can reduce carbon in concrete, right through from sort of design through to sort of specification. But ultimately, we agreed on an overall requirement to use the lowest carbon concrete to meet the performance requirements, and then we've produced, you know, a set of specific requirements that sit under that and some guidance. So in terms of summary, it's looking at maximizing the amount of cement replacements whilst achieving performance requirements within the concrete standards for most of our critical structural uses, but then maximizing opportunities to use some of the even lower carbon concretes that are on the market and emerging onto the market as well, and looking at alternative reinforcements to steel as well. So a combination of that approach, we think we can save something like 50% of our construction carbon footprint, so something like 25% of the overall footprint, so really significant. Then another category looked at was modern methods of construction. This obviously covers quite a wide range of activities, so from I guess familiar sort of precast solutions to sort of whole assets being built offsite and literally brought in and installed on site. So recently got some learning from 3D concrete printed steps, which is the sort of bottom left example. But overall, we agreed this is quite a significant piece of work that we needed to do as a separate project. So there's not much in our engineering requirements about this, other than that we should look at as it at a default for MMC, for modern method of construction where possible, but to sort of check whether that's the right approach each time for hard assets. Then we looked at steel piles. So a lot of this was around looking at alternatives to steel piles in terms of lower carbon solutions, whether that be things like plastic piles or trench mix solutions for below ground cut-off walls, etc. Then looking at design optimization when we're using steel piles, and then finally the sort of the carbon assessment around the piles that you are using in terms of specification and sourcing as well. So there's some interesting products on the market, coming onto the market in that area as well. And then site setup. This was a really interesting area where in the main we look to have mains connection for our construction projects, but that isn't always feasible, particularly for some of the sort of shorter duration projects, or in some cases where we've got satellite pockets of work going on with satellite compounds, etc. So where we haven't got mains connection with the eco tariff, then we'd be looking for the lowest carbon solution in terms of energy provision, cabins, etc. Using a range of different solutions, but ultimately looking for that sort of optimization to happen up front. And alternative fuels, are again a part of that mix. And we're seeing some good work in that area with lots of trials and pilots of different sort of renewable solutions, complementing some more conventional solutions like the diesel generators. But often we're seeing the diesel being swapped out for alternative fuels, which we'll come on to. And then in terms of site, plant and transport, so we recognise this is an area where there's an awful lot of emerging technologies and technologies which are maybe not widely available at the moment. So it made it quite hard to have a a widespread blanket sort of requirement. So what we did here is had a hierarchy approach. So again, the lowest carbon option, meeting the performance requirements of the job. Moving from things like electric plant, hydrogen, hybrid plant, through to sort of conventional plant with alternative fuels. But importantly, that being the sort of minimum requirement without sort of a prior agreement from the Environment Agency project manager on that. And we're seeing quite significant movements as a result of that in terms of how we're fueling our plant on site. So I guess moving into alternative fuel. So I guess this is we're often talking about HVO fuels, and we're seeing a really big change in provision on site. So in effect, it's a swap out option for diesel in a lot of plant. Site was at on Friday. They didn't have mains connection, and they did have HVO in the diesel, in the generator that would have been a diesel generator on that site. But that is, I'm seeing that across a lot of our projects now. So I think that sort of minimum requirement is pushing people to look at that option. But at the same time, we are seeing other sort of solutions being piloted and trialed at the same time. And just one example to finish up. On our lid ranges project, which is coming up this summer, we're seeing it's probably our biggest use of HVO. So it's 400,000 litres of HVO used over a 3-week period, saving something like 1,200 tonnes of carbon. So that's being used to transport and place shingle as part of the beach replenishment work. So that's in tugboats, trucks and dozers on the project. But I think I'll leave it there, and I know following speakers Simon and James will be talking a lot more about HVO in detail. Thanks very much.
Great stuff. Many thanks, Andy. Just a reminder to everyone, if you've got a question, we've got the Q&A function there on your screen, so please do put questions in. We've already had one come in so far. I'd like to next introduce you to Simon Lawford, who is the Technical Sales Manager for Crown Oil. Simon has over 25 years experience in the fuel and lubricants industry. He started his career as an R&D chemist, designing and manufacturing innovative products for use as lubricants in applications such as wind turbines, hydraulic fluids and compressors. Since then, he's worked in several different functions, including sales management, marketing and technical aspects. Simon joined Crown Oil in March 2019, where he's responsible for driving Crown Oil's efforts in renewable and sustainable fuel sector. I'd like to hand over now to Simon. Many thanks.
Thank you very much, Chris, and good afternoon, everybody. You've already dropped a hint there, Chris. Apologies, everybody. I am a chemist, so there will be chemistry in this presentation because I just can't help myself. So first of all, then, just a few headlines, 4 headlines, if you like, to give you an overview about what HVO can offer. So first of all, the clear one, HVO offers a net 90% reduction in GHG carbon dioxide. Net being the key word or the key phrase there. HVO is, in terms of chemist speak, it's a hydrocarbon. It just happens to be manufactured from new carbon rather than old carbon. And that carbon is locked within a short lifetime or life cycle. I'll take you through that a little bit more. But ultimately, if you do test any emissions on HVO versus diesel fuel and you look at CO2, you don't physically get any difference in tailpipe or very little difference in tailpipe because the testing machinery can't tell the difference between new and old carbon dioxide. HVO, it's manufactured, or certainly the material that we provide to the market is manufactured from 100% renewable and sustainable waste-derived materials. In essence, HVO can be manufactured from any type of biomass, as long as you can get it into the right physical state to pass through the chemical plant. You know, there's no reason at the moment that feedstock tends to be, the majority is used cooking oil, as it would be for biodiesel fuel, but there's no reason why you wouldn't be able to manufacture HVO in the future from grass trimmings, for instance. It's certified, products are certified as sustainable and renewable by an independent third party. In our case, that's ISCC, who are a global organization responsible for this type of process, and that's key. You must have an independent certified and approved certifying body in order to be able, the fuel to be able to be accepted by the Department for Transport for use within the road transport fuel obligation. That RTFO is critical. Without RTFO approval, then we're unable to claim carbon tickets, carbon RTFCs, and we're not able to then effectively sell the fuel at a marketable price. HVO is a drop-in fuel. As I've already said, from a chemist perspective, it's a hydrocarbon, and we've proven now, although it was long known, we've proven certainly within the UK that HVO is drop-in. You can literally run down your diesel, put HVO in. There's no changes required in engines or in critical infrastructure or delivery infrastructure, and everything will run with no hassles at all. Therefore, there's no upfront capex cost to switch into HVO. As well as the net 90 CO2 reduction, GHG CO2 reduction, you also get significant reductions in noxious tailpipe emissions. These are harder to quantify, simply because the emission from an engine is more engine specific than fuel specific. It really does depend on how the engine is being operated at the time, where it's being operated, how old it is, how well maintained it is, etc. But certainly significant reductions are achievable and will be achieved. As I say, difficult to put your thumb down as to what they will be, but I've got some examples later on in this presentation. Here's a chemistry bit. Certainly in the early days of when we started to bring HVO into the UK, there was a fairly high degree of pushback because the assumption was that HVO is a biodiesel. It isn't. It's a renewable diesel that just happens to be produced from a biocarbon source. That carbon source, as I say, generally is a fatty acid in the form of used cooking oil. If you see the black dots here, these are carbons, the white ones hydrogens, and in this instance, the red ones being oxygens. That's a schematic, a very simplified schematic of a fatty acid. We would use that fatty acid if we were making biodiesel. Rather than hydrogen here, we would have methanol, and we would react the fatty acid with methanol to produce an ester, biodiesel. In this instance, because we're using hydrogen, in essence, we knock the oxygens out of the molecule, and then as you can see here, all you've got is carbon bonded to hydrogen, a hydrocarbon. That's a paraffin structure. That is the good bit of diesel fuel. Diesel fuel is a blend of different refined products, some of which are good paraffins, some of which are not so good in terms of the overall operability of that fuel. So Ultimately, the purity of HVO gives us some defined benefits both over biodiesel and over standard fossil diesel fuel. In terms of benefits then for biodiesel, we've got a consistent product. It's coming out of the reactor in a controlled manner. Obviously, the chemistry that's going on is well controlled, so we have a defined product coming out, and it's not blended with anything. It's a true diesel fuel. As I said before, biodiesel was an ester. We've still got these oxygens in there, and ultimately that's more of a pseudo diesel, more diesel-like than being a diesel fuel in its own right. HVO isn't that way. The engine is actually running on or burning what the engine is designed to burn. Because there's no oxygen, no ester, no double bonds, no unsaturation, the fuel itself has a long storage lifetime, 10 years plus. That is particularly important for industries such as maybe data centers, where they have fuel stored just in case grid power should go off and they need to kick in emergency power. You don't need to heat HVO in any way, shape or form to keep it mobile in tank. It doesn't block filters in cold temperatures. The CFPP, the cold filter plug-in point of HVO, is anywhere down to about -32 degrees C before it'll freeze. So even in the far reaches of Scotland, we would be okay. And crucially, it can be mixed in all proportions with mineral diesel. So you can either go empty your tanks, make sure your tanks are clean, put HVO in, move ahead. You can dump HVO on top of diesel. And crucially, if you do go HVO for site-specific operations, but then decide that you could use diesel elsewhere, you can change back. You're not wedded to HVO in any way. Some benefits then versus fossil diesel. As we've already said, it's a non-blend, it's a consistent product. Diesel fuel down here in Dorset would be different to the diesel fuel up in Leeds, simply because it's coming out of a different refinery in a different blend fuel. There's no aromatics. What is an aromatic? If you can imagine this carbon attached to this carbon, you have a ring structure. None of those in HVO. Aromatics cause issues such as carcinogenic health issues. They also don't burn particularly well, and are quite a contributor to the black soot and smoke that you get out of diesel fuel. Because of that, HVO is obviously reduced health and environmental risks. And we see fuel savings with HVO in many, many cases. We've got reduced particulate matter, and as we've already said, NOx reductions. In terms of the CO2 saving, it's all about life cycle. So the HVO life cycle, i.e. the difference between the emission of CO2 and then the sequestration of the CO2, is around about one growth cycle. It's a plant-based product. Indeed, because it goes one step further, because it's a waste-based, plant-based product. So the carbon footprint of the growing of the plant initially is put to the original purpose of that product. So in the case of Crown HVO, that would be the production of cooking oil. Fossil lifetime, obviously, fossil fuel is actually plant and animal based. It just happens to be dead dinosaurs from 2 billion years ago. And that's the issue. The fossil life cycle for carbon is millions and millions of years difference between the emission and sequestration of that CO2. If you think about it, the crude oil that we have in the Earth's crust today is a carbon sink of millions of years worth of carbon, and we've let it go within roughly 150, 250 years, which has increased the overall concentration of CO2 in the atmosphere. That doesn't happen with HVO. What goes up 90% of which comes back down within a year. So since we first started this journey with HVO now 3.5 years ago, it was at that time a pretty difficult conversation to be had. Why? Well, it costs more money. I'm not going to put that biodiesel muck into my engines, etc., etc. But we've had a fantastic growth period. We've proven the benefits of the fuel, and ultimately we're seeing HVO being taken up across the board, really. We have fuel operating in fleets, in delivery fleets. We have local councils and government agencies taking up the fuel. My local council down here in Poole is running their dust cart fleet on HVO. So every Monday morning I give it a little wave as I see my bins being collected. James will talk a little bit more about what Land and Water are doing with the fuel. We are within the data centre in the emergency power sector, and of course, although it's not represented on this slide, we are also operating in the rail industry as well, with trials pulling 7,000-ton trains, and the fuel has operated faultlessly across the piece. But looking a little bit further in marine, we are slightly hampered with HVO and biofuels in general in marine, in as much as the RTFO doesn't allow for the claimant of RTFC tickets in anything other than inland waterways, which means that the fuel is pretty expensive for international marine fleets. But we are operating on the Thames, certain large operations such as Corey. They've done some extensive trials, and we are now filling their tugs. So Corey pull around about 1 million tonnes of recyclable and non-recyclable waste down the Thames into their sites, and those trials looked at the efficacy of the fuel and also the emissions. So in terms of NOx reduction, we saw 18% NOx, 21% plus reduction in particulate matter. Over the trial, we saved around 50 tonnes of CO2, and importantly, Corey now see around about 4% reduction in overall fuel consumption, but also they've been able to double their engine oil change interval from 800 hours to around about 1600 hours. So there are ongoing savings for Corey as they continue to operate. And I see I'm running out of time, but just to round off, HVO is now proven. Its benefits are tangible. It's got legislative backup. Its performance is very well accepted. It's definitely environmentally beneficial. You have a fast and simple step toward net zero, with importantly no capex requirements, and certainly its operability in the field is under no question. I'd like to thank you. Apologies if I'm slightly over time. My contact details are there.
Brilliant stuff. Thank you very much, Simon. I see we've got lots of questions already coming in, which is brilliant stuff. We have one more presentation to come. This is from James McLean. James is the CEO of Land and Water Group. He's a co-founder, in fact, of the organisation. He's going to be talking about behavioural change and the work that Land and Water Group have been doing on their decarbonisation journey, to sort of talk around how the process has worked, what they've learnt, and how they're taking that forward. So I'd like to hand over straight away to James. Thank you.
Thank you, Chris, and good afternoon, everybody. it's always useful to start with a picture of some heavy metal because it gets everyone's attention. So there's a picture of some heavy metal with stacks and stacks of embedded carbon in it. Very briefly, Land and Water are environmental contractors. We believe in designing and building nature-based solutions as part of our drive to net zero, as well as our core business of marine works and plant hire, and a number of interesting joint ventures. But interestingly, we are developing the code for the wetland carbon code for trading carbon on the wetlands that we're looking to create, and that's a project we're undergoing at the moment. So the size of our business, we turn over £50 million and we employ about 200 people, but principally we work where land and water meet. In my presentation, because it was done late last night after a problem with OneDrive, you'll find 3 mistakes as a prize for anybody who finds those. Apologies. So what I'm going to talk you through is why we've looked at HVO and how that came out of the carbon counting that we've been doing. I'm going to briefly look at the advantages of HVO for our business and the risks to our business of using it, what we have learned from a series of full-scale trials, and what we're doing next. So first of all, the journey started with an assessment of our scope 1 and our scope 2 carbon impacts. And that gave us a depressing figure that our scope 1 and scope 2, so this isn't necessarily all site-based client impacts, is 3,486 tons of carbon in the pandemic year. And what really, really scared us was the green part of the pie chart, which you'll see in front of you, which effectively is our fossil fuels. So a significant proportion of the impact of our business is driven by our scope 2 diesel costs or diesel impacts. And then we worked out how many trees we had to plant to try and offset that. And the thinking here really shows us that offsetting doesn't work. It's the final last resort. It is not a solution. So to offset our business alone, we need to plant 13,932 trees in a year, and we need to leave them growing for 40 years to offset 1 year of trading. So behavioural change, not incurring the impact in the first place, is the biggest single win. Offsetting is the last final resort. So we've looked at behavioural change in our business, and we put a team together that mapped out all the changes that we think we can make and then set some reasonable timescales to them. But the biggest single decision right at the front of that route map, the golden, the yellow brick road, is the reduction of gas oil impacts. And I think HVO is an intermediary technology. Because we can use it now, it's a simple win. It might well not be the end game, but it is certainly a lever we can pull right now, and it has a significant impact. So let's look at the advantages. And we did work with Crown Oil on an extensive trial, and I will come on to that in a minute. But ultimately, the advantages are considerably lower carbon than a fossil fuel if we consider the 1 year cycle versus releasing mineral oils from 4 million years ago. Lower NOx and lower particulates. It can be mixed in the tank and therefore mixed with the existing gas oil, thrown straight in and used it. And we tried that and it worked. It's available off highway and as a white diesel. There's no risk of diesel bug because it doesn't have the ester link that you've heard about from Simon. And importantly, it has a 10-year storage life because we were finding coagulation and diesel bug in our Bowsers using conventional biodiesels. We also noted considerably extended filter life and service intervals, the same as the Corey's trial. And the less risk of waxing in the cold temperature, particularly when we conducted the trial. It looks really sunny in that photograph, but it was a miserable February and March. Also importantly, because much of our work is in sensitive habitats, it's a biodegradable product. And I think we've all made a big move in industry looking at biodegradable lubricants. Our entire fleet is biodegradable, including our tugs. But actually the fuel was still mineral based. So having a biodegradable input fuel is significant in terms of risk management. And here's the big point, and I want you to go back to the picture at the beginning of my slide of the big heavy machine. It allows us to use the embedded carbon we already have in older parts of our fleet. And I know certainly talking to the Environment Agency about that, we had the same conversation about their aging Land Rover fleet. Because that carbon's already been spent. It's locked up in that machine's 105 tons of steel. That steel was committed 7 or 8 years ago, but it's still available to us. So rather than just a quest of always buying the leanest, meanest, most expensive, highest appreciating asset, by using HVO, we can actually use the embedded carbon that's already in our business. And we've been talking to Caterpillar and Hitachi and JCB about repurposing machines in the future so that we can keep as much embedded carbon as we can, and upgrading power units and upgrading electronics, but keeping the steel that's already there. And I think that's a more intellectual way about looking at the longer life of our assets. And also, one of the advantages we've noticed, particularly in the last 12 months, is that the supply chain is maturing. And the supply chain goes both ways, both in the supply of the product, but also in the people that hire equipment to us beginning to accept and understand that it doesn't ruin their engines. And I should emphasize that in the trials that we've done, we have had no impact, mechanical or otherwise, or lifespan in any of the kit we've been using, and that's both land-based and marine. So what are the disadvantages to it? Well, we're in a dinosaur industry that's slow to adopt, and it is actually quite a simple idea, and I'm surprised we haven't seen a quicker uptake. The cost was a disadvantage, and I know in the chat there's been some questions about costs. We are currently buying HVO on a 3-month fix between 66p and 70p a litre, which puts it bang in line with current gas oil prices. There was concern about surety of supply. We haven't seen that, and we've seen continuity. And initially there were concerns from the OEMs about warranties on equipment. Again, we have not had any pushback from manufacturers. And I've always had a slight concern that over demand of this product has a potential long-term conflict with sustainable food supply, because we're going to need to grow it. And I think with the population of this planet going from 5.7 million to 7 million by 2030 and 9 billion by 2050, we have a real challenge growing enough food. So Simon's throwaway line about using grass clippings but other biodegradable waste has a role to play in making sure this supply is sustainable. And I think we did have concerns about engine performance. But what I'm going to come on to show you is actually the outputs from our trial. And this was a 600 engine hour trial. This machine was a 25-ton Hitachi excavator, almost brand new. And the left hand of these charts tracks its performance in January, and the right hand track is its performance in the trial period, February and March. Now, this machine was working on the Thames Tideway project at our Rainham Marshes habitat creation scheme, where we're reusing the tideway spoils for habitat creation. And you'll notice in the orange boxes above that machine's working between 12 and 21 hours a day, because we're handling tunnel spoils 24/7 here. So there were periods when this engine literally didn't switch off for the trial, and we were changing operators in and out of the seat. And what's interesting is that we set the power rating, which is the left-hand bubble, at 100%. So the machine is working as coarsely as it can. So this is the heavy lift option switched on, operating under maximum load for the longest possible hours. So I think if you're going to find a problem, you're going to find it here at 21 hours in a day. And what's really interesting in the bottom chart is that the average fuel burn at maximum load was running at 15.6 litres an hour. But with HVO in the March period, we were seeing this overall reduction in fuel as well at 14.1 litres an hour. So the 4 to 5%, which was recorded by Corey, we're finding exactly the same data coming out of the telemetrics. So 600 engine hours in a brand new machine, Tier 5, highest quality engine. If you're going to find a problem, you're going to find it in this. We've also run it in our older tugs. We've run it in very old equipment as well. And we couldn't find any discernible impact. So that's real live data that's come out of a real live trial, working the machine as hard as is almost humanly possible. So what have we learned about it? We've learned it's easy to use. We've learned we don't require any engine modifications whatsoever. We found it's readily available. We have this 3 to 4% saving by volume. We have lower carbon and lower overall emissions in particulates and NOx. No operator training was required to adopt it. We put it straight into the Bowser and it was used conventionally. It runs on all engines that we tested, old and new. And And more recently, our supply chain hirers are adopting it, and the cost is close to the gas oil equivalent. So the decision that we've made across the group is to switch all land and water companies to 100% HVO by the 1st of November this year. So we've been running it on and off for a whole period. We've made the decision and we're implementing now, and we're spreading that across 2 suppliers so that after a 3-month or 4-month trial period, we can decide which supplier is giving us the best service. So we believe it works. We've tried it as hard as we can and we can't break anything, and our supply chain is beginning to move with us. Thank you very much indeed.
Brilliant. Many thanks, James. Just wait for Andy and Simon to come back on screen to join us for the discussion. I'm pleased to say we've got lots of questions in. We're aiming to finish around about 3 o'clock. It might just be a little bit after. I can't promise we'll get all the questions in, but we'll obviously try our best. I'm off also as well to try and work my car on grass cuttings. Got more chance of getting that than I have of diesel at the moment. Anyway, moving on. I'm going to sort of summarise quite a few of the questions around the performance of engines around HVO and how that compares to diesel. So I mean, speaking from my sector, plant hire, how easy would it be for one of my members tomorrow to say, right, I've got about 10,000 litres of red diesel left. I want to make the switch over to HVO. How quickly can I do that? And I'll aim that one to you, Simon, as the supplier. How simple would that be in terms of both depot storage, but also making the switch in terms of running out red diesel from engines?
It really depends on how you want to do it, but ultimately you can have it tomorrow. We have the fuel now in our own tanks. We have 9 tanks that are storing the fuel. They go across the north of the UK, down the spine, and in the southeast and southwest. We've also got a network of people or organisations that we work with that are taking our fuel. So ultimately, and it sounds a bit of a cliche, but we can cover Penzance or Land's End to John O'Groats with HVO supply. Of course, there are areas that are harder to reach and lead times are slightly longer, but in general terms, anyone can ring up and order 10,000 litres and get it within standard fuel lead times. In terms of changeover, we do recommend that tanks are checked, etc., simply because if you're going to run a tank down and you've got muck in the bottom of the tank and it stirs up when you put the HVO on, I don't want you to blame my fuel. But ultimately, you can, and we have clients that simply have just topped up their current diesel tanks and run the HVO through it that way. And therefore, over time, they've made that change. Really is down to up to you, and we can help you facilitate it whichever way you want to do it.
Brilliant stuff. Thank you, Simon. One of the questions that we've actually had in is actually a very interesting one that I've not thought of before, but and I think this has already been answered, but forgive me for asking it again. Can diesel and HVO be mixed? James, I'll let you elaborate on that, and Simon.
Oh, sorry. Carry on, James.
You are mute. Sorry, James. I was saying, go on, Simon. He can answer it. The answer is yes. You can tip it in the same thing from me.
Yeah, indeed. It's 100% miscible from 0 to 100%. The key point is that HVO, although it's new carbon, is a hydrocarbon, and people tend to believe that hydrocarbons have to be dug out of the ground in terms of from crude oil. Hydrocarbon is just a chemical term of carbon stuck to hydrogen. So there is no issue at all with HVO mixing with diesel fuel.
Brilliant. Thank you, Simon. Question for Andy here. Do the Environment Agency, this is slightly just different bent on the questions, do the Environment Agency now insist on companies working within their framework adhering to decarbonisation guidelines? So sort of wider look at the decarbonisation process, Andy.
Yes, I mean, in effect, the work that I was talking about in terms of task and finish group, which was actually commissioned by our National Engineering and Innovation Panel in the Environment Agency, which owns our engineering standards. So it doesn't sort of sit as separate carbon guidance. It's actually been incorporated into our engineering requirements in effect. So all new contracts from May, certainly on the main frameworks for the larger projects have got it in, and we're working with our operational framework to get it into the ones for sort of smaller works as well now. So.
Great stuff. Thank you, Andy. Question in regarding sort of looking at the marine industry itself. Are there any large scale examples of HVO being used on a large scale currently in the marine industry? Question for probably Simon or James on that one, but Andy, if you've got an insight into that as well, please do.
From my side, I wish there were from the UK. Unfortunately, the rules of the game, as I've said before with the RTFO doesn't allow fuel or biofuel to claim RTFC tickets for marine use. However, if we just go over the water to our friends in Holland, where they do allow their version of RTFO for marine, then many vessels are filling with HVO and going out on international journeys. There's a number of actually companies that are based over there that have asked us to supply them for with marine fuel, which we're happy to do so, but we can't claim the tickets, therefore it's expensive, and that has been the biggest barrier. But there's, in terms of its cleanliness, if you compare HVO with marine diesel, then there really is no comparison. HVO is just much better fuel.
Great. Thank you, Simon.
Sorry,
Andy, go on, please do. Yes.
Yeah, I was just going to add. I think it's changed. I think in the smaller vessels, the tugs, we're seeing it, but maybe not in the moment. I think on our Linkshore project and Saltfleet to Gibraltar Point project, which was Team Van Oord, they used a B50, which I think is a blend of biofuel and marine gas oil. So that's what we're seeing at the moment, rather than 100% sort of switch to something like HVO.
Absolutely. Question for James, in terms of sort of your use of HVO, are you also looking at electric equipment as well, hydrogen as well, or is it solely at the moment HVO focus that you're looking at as part of your decarbonisation strategy?
So I think we're looking at HVO driven hybrid electric tugs at the moment. In fact, we got some hybrid electric cutting boats on trial at the moment with the Environment Agency. Exciting technologies. One study we did on a small tug showed, I'm struggling back for the numbers now, but we're looking about 65,000 litres saving on conventional gas oil over a 3-year lifespan on the hybrid, because a tug spends a lot of time stood. So big diesel engines are just a thing of the past, really, in a tug. But fundamentally, the whole thing starts with behavioural change. Let's try and design out what we're doing first before we decide how we're going to fuel it, right? And a lot of our thinking is about trying to change the way we deliver projects completely, rather than just delivering this. That's why I think HVO is an interim technology. What we have to do is look further up the design change and see how we can design down the carbon impact at the first point, and then HVO and hybrid tugs and all the other things are secondary decisions, and the final decision is offset. But that thinking up the chain is where it all starts, and I'm not so sure that we've grasped that concept yet.
One of the questions actually really that I think looking broader is, and again, this is probably one I think for Andy with his environmental agency hat on, how good are we, the UK? We sort of talk around the UK as being a world leader when it comes to setting its targets and being the first to try and decarbonise its wider industries and achieve net zero. How good are we at that when compared to other international competitors? How does the UK fare, especially ahead of COP26, when no doubt the government will be talking up its credentials and the journey we've been on?
I'm not really sure. I've got an accurate answer for that one, to be honest. I mean, I guess in the role that I'm in, I just look to see what everybody else is doing, and I don't particularly mind too much who's top of the table. It's just making sure we know that we're learning from everybody else and you know, doing the best that we can be. So I mean, certainly we are doing an awful lot in this country in sort of moving the agenda forward, but equally there's a lot happening in other countries as well that we can and are learning from. And I think, you know, the more that we all do that, the better for us all, because there's no point being top of the table, but everybody getting relegated to take that on to the conclusion.
Great stuff. Thank you. Thank you for that, Andy. I think we are virtually, I'm afraid, out of time. Hopefully, though, we will be able to continue the debate moving forwards. I'm sure we can share presentations as well. I'd like to thank Simon, James and Andy, both for their presentations, but also for the debate as well. Please do continue sending your questions. Hopefully we can answer them in due course, and also make sure that we take this debate forward. Decarbonisation, very important area, very important issue, obviously, both within construction, we're in the marine industry, where a lot of companies, I think, are very much at the start of their journey. So this is really a way of sort of taking stock, finding out what's going on and how that can impact on your business. I'd like to basically say again that a recording will be available to all delegates in the on-demand section on SeaWork Connect. Decarbonisation, what it means for you and how you can help your business, will return for a second event in February 2022. In the next session, there'll be a focus on construction materials. So please do look out for further information about that. So make sure when the date's confirmed, it's in your diary. I'd like to thank everyone once again for taking part. Sorry we didn't get through everyone's questions, but many thanks again to the presenters and also Peter as well. Thank you very much. Bye-bye.